So this is the third video in the series where we're assembling an MSAI 8080 MPU-A CPU card. In this video, we're going to address all the discrete components. In the previous two videos, we looked at the resistors and the sockets. So let's dive in. So in this video, we're going to continue the assembly of the MPU-A board, moving on to the discrete locations. So the discrete component location starts down here, and it has us and solder in the 16-pin socket up here in this corner, and actually has us solder in the 40-pin socket down here. Why those sockets are under discrete? Well, it's because it would have been the original kit, the only two sockets with the kit. All the others would have had the logic directly soldered to the board. This position up here, A10, is where the ribbon cable goes off to the CPA panel. And again, pin 1 is marked. I'm going to use a machine pin socket there myself. You may or may not have a colored socket in your kit. You probably won't. But if you do, the colored socket could go here just to differentiate it. Let me put on the good glasses. And we'll get in here and do our normal corner pins, flush, solder process. I suspect that socket isn't flush. Oh, maybe it is. Ow, pin got hot. So we've got him in place and he's flush, and we'll hit all the pins on him. Like I said, there's a ribbon cable on a header that'll plug in here that runs over the top of the machine and down in behind the CPA panel. It brings the data bus directly to the board here so the CPA can control the data going to the 8080 directly to perform its functions. So that is in, and that called for the 40 pin for the 8080. There should be a single 1N914 diode in your kit. I have it right here. There's also a Zener diode. Excuse me, it's marked here. I believe this diode is on 0.5 centers. I'm going to try to get it centered up in the tool as well as possible. The orientation is shown here in the diagram, and it's also in the top layer of metal, copper on the board. There's a little symbol of the diode, and the little line, you probably, I don't know if you can see it or not here, there's a little diode symbol there. The little flat line goes to the black line on the diode. At least typically that's where it connects. So we'll go ahead and drop it in. Solder up. And then it has us immediately go on to the 5.1 volt Zener. And I believe it's on 0.5s. It looks like it is. Yeah. I'll just go ahead and get it mounted, and we'll do some lead trimming. So let me get the paper tag off this. So this is a Zener diode. Apparently it's a 5.1 volt Zener. And same thing, there's a marking on the board that shows the orientation of the diode. The black line on the diode goes towards the flat line in the symbol. And that's also shown up here, right here in the diagram. I believe this produces the -5 volt rail for the 8080, if I remember correctly. Again, this lead here has got a large copper pore, so it may take some more dwell time to actually get a good solder joint, because it's got to really heat that copper up. And as the original board had, I've said it several times in the previous videos, there's no thermal relief here to make soldering that easier. So a little bit of extra dwell time. We move on to the 18 megahertz crystal. This little guy right here, it even says 18 megahertz on it. I have a piece of double-sided tape on mine to hold it in place. It's going to mount up here where the crystal's shown. This is a case where I need to grab a little pair of needle nose pliers. Excuse my reach. Assuming I can find some that I think will work for this. I want to bend the leads out and try to keep it looking somewhat nice. I'm just holding the leads here and gently bending them. I don't want to put a lot of mechanical strain through. It looks like that'll bend down right about there. I think about the same width for the other side will work. Just trying to keep the install nice and clean. He drops down into here. I recommend double-sided tape. I don't know exactly how the kit will be kitted up. So don't know if you'll have double-sided tape pre-installed or not, or be provided a piece. So I don't know at this point. So that's something I'll take up with Robert next time I speak with him. We'll actually be doing the kitting. The original 18 megahertz crystal was in a much larger package. It's harder to find those. It's almost impossible to find that size package at 18 megahertz or at any frequency anymore. It's just one of those things that hasn't been made forever. So this is a case where a more modern package is being substituted there. So, and then there's a 39 picofarad capacitor. So there's going to be a group of disc caps. I think there's 9 here. They're the same. Some tantalum caps, 5 of them here, and a 39 picofarad. And this literally says 39.5% on it. So he's going to go here. I'll get him in there as best I can. Hold him square, flex the leads. Set the board up off the tabletop so we're not putting pressure down on the top of that capacitor. So that got the 18 megahertz crystal and this 39 picofarad capacitor. Let's talk about these two crossed out areas. There's a section crossed out here for a 1 microhenry inductor and a 56 picofarad disc cap. Those are not required with this style of crystal. The really early MPU-A boards required that inductor and a couple of diodes for what was called a tank circuit for the oscillator that generates eventually the clocks for the 8080. This is a more modern crystal that doesn't require those, and IMSAI pretty quickly moved to using this style of crystal and not having those components. So they're just marked out here as they're just not required in this design. So we're going to move on to the 0.1 microfarad discs. Get the other glasses on so I can see. You'll most likely have these in your package. In this case, it's labeled 104M. 104 is a 0.1 microfarad disc cap. 103 is a 0.01, etc. So it's either going to say 0.1 or 104 on your caps. We get one here, if I can get him in. So while we're working on caps, let's talk about tantalums for a minute. You'll have 5 tantalum caps in your kit. They look like these, drops. They may be a different color. The markings on them may be different from the markings on these. So these tantalums are polarized, and they need to go in the proper orientation. If you don't, they tend to explode when you apply power to them. So let me take a look at this and figure out the orientation. So in my case, so the long lead on this is a positive. Well, is that true. 23 or 33 plus, yes. Markings just depend on manufacturer. So the long leads appear to be the positive. On the board, and you probably won't be able to see this, there's some locations for these tantalums. There's one here, and there's a little plus sign in the copper underneath the silkscreen that tells you the orientation of the cap. And that plus sign is also the indication that a tantalum cap goes there and there. There's two that go down here on the power supply. The positives are toward the center here, and the negatives are out. And there's one more that sits up here. Its positive is on the bottom, but like I say, the silkscreen, or not silkscreen, the copper markings in the copper will tell you the orientation for the cap. So there's 2.1 microfarad discs that go in here. We'll get these discs in. Gets the 9.1 microfarad caps in place. You can notice here that 10's crossed out and 9, and that C4 is a location that isn't used. That C4 would have been part of that tank circuit I mentioned earlier. There's 5 33 microfarad tantalums. We've already talked about these. Your tantalums may be a different color, as I've already said. You need to look at the marking. Sometimes the negative leads mark on the package, sometimes the positive. It just really depends on the manufacturer. So I'm going to get a couple of these in here. And then the one for here, the positive lead goes down. Just double checking the marking. I try to get these so they're in square to each other. It's not always easy to do. Gets the tantalums in, 5 tantalums. The 78L12 is a minus 12 volt regulator. It's this little guy right here. In the copper on the board, under the solder mask, you'll see a little symbol here that shows the direction the flat faces. In this case, the flat faces to the left with the board held this way. Get him down in there. Get him square. Good enough. We're now just down to the voltage regulator and heatsink. So I need a Phillips, excuse my head. tend to line it up. Take a look at where I need to make the bends. Look one more time. It doesn't look just out about there. Nice and 90 degrees. And same about distance here. The center one is going to have a much tighter. I'm lining up on the screw hole as I look to judge where these get bent. The center one actually gets bent back in the wider part here of the shoulder. Get it to drop down in there. I'm just going to flare the leads a little bit to hold it in place, because I've still got to be able to get the heat sink up underneath it. In this case, there was a second heat sink there on this heat sink. I'm not quite sure why that was there, but it was. Some heat sink compound would be recommended here. I'm just for time, I'm not going to actually put any under there, but it's recommended. I like to get everything in square first. And then solder. If you solder the regular in first and then drive the screw and get the heat sink under, you put undue stress on the leads you just don't need. So get everything mounted where you're happy and then solder up the leads. And that way there won't be mechanical stress in that solder joint that will eventually lead to, of course, a solder crack and a failure of the board. This ground pin here has got a lot of copper on the other side of the board and this side to deal with, so a little bit of patience. Let it fully get up to temp. As you can see, my dwell time there was rather long. I can see on all three pins here that the solder flowed through to the other side, and I got a nice looking solder joint on both sides at the same time. And that was just going with sufficient dwell time to really get everything up to temperature, and then gets me a nice connection of the regulator to the board. I think that finishes all the discrete installation. There's a couple of solder joints here I'm not thrilled with, but there always are. Well, I appreciate you watching the video. If you liked it, go ahead and give me a like. I appreciate it. If you're not a subscriber and there's content here you'd like to see, I'd encourage you to subscribe. In the fourth video, we're going to dive in to getting the chip stuff and kind of finishing up the board. So anyhow, I appreciate it. I hope to see you in a future video.